Web APIs are everywhere, and making requests to them is often a necessary part in a data analysis to even get the data in the first place. And in the age of AI, you will also need to make API requests to talk to a GPT like ChatGPT in an automated way through API requests. Welcome everyone, my name is Albert Rapp, and in this video I'm going to show you how to communicate with APIs from within R. You see, APIs are everywhere and they can give you a lot of data, but if you don't know how to communicate with them, it can certainly feel like the data is hidden behind a layer where you don't have any clue how to get to it. But with the httr2 package, the workflow to get to the data through the API is actually always the same regardless of the API. And in this video, I'm going to give you a detailed guide how to operate this package so that you can finally get to your data through APIs. All right, in level 1, we are going to make a request to the US National Weather Service to get a weather forecast for a specific location. And in my Quarto file, I've already sketched out the workflow that the httr2 package requires so that we can make a request to an API. The principle is always the same. First, you will have to load the package, of course, and then you will have to use the request function where you stick in a base URL. In our case, we will throw in a URL from the US National Weather Service, which is specifically the API URL, so that we can make requests to that URL. That's what the request function needs. And then we pass that object to some request underscore function. There are a whole bunch of functions like this for all kinds of use cases, and we'll see a couple of them. But the point of this, just like in ggplot where you use gm underscore point or gm underscore line to use the geometric objects that you need, you will use these request underscore functions to make the request appropriate to what an API needs. And then once you've assembled everything through this process, you can actually make the request, and this will give you a response which you save into a variable, and then you can evaluate this response via a response function depending on what you get back from the API. So this was a high-level overview over how to make a request to an API. And broadly speaking, this also tells you what an API even is. It is something that you can address somehow, throw some code at it, and get stuff back. And the magic of communicating with APIs is making sure that what you throw at it is in the format that it likes. That's why the workflow is in there to make this as easy as possible, and then untangle what the API gives you back. And this is why you need a function to untangle the mess that you get back. So now let's make this more specific with the US National Weather Service. You see, if you Google for API, US National Weather Service or something, you will get to a website that looks like this. It isn't very pretty, but it tells you the URL that you need to communicate with the API for a specific location. There's even an example URL here, and the cool thing about this API is that you can sort of make the request manually. You see, if you follow this link, you will actually get the response back inside of your browser. This is a whole lot of gibberish, and this is what I mean by you have to figure out how to untangle the stuff that is given to you by the API. Some things you can make out here, for example, is the geometry, for example. This is the coordinates of the point we're looking at. And if we look in here, we also see that it has some property, which is called forecast hourly. And then we could follow this URL here. And if we put this into our web browser, we get even more stuff back. And then if we scroll all the way down here, we see that there seem to be forecasts for specific points in time. So this was kind of the making I requests manually. And usually you cannot do this because you have to use some other steps in between, like authentication. But with this API, it's kind of neat that you get to see this whole process manually. So now let us try to figure out how to make this happen with the httr2 package. Back on the website, we have seen that we got this URL here. So let's copy this and go back to RStudio. And now let us set up a new variable. Let's call it base URL and throw the URL in there. And what you can see in this URL is that the base URL is basically this part here. And all the things that we have on top of that, where we need to stick in stuff like the latitude and longitude. So basically the coordinates of the place we want to look at. We have to stick this in there, and depending on what you stick in there, you get other results back. If you look at our example from before, you see that in there were a couple of coordinates already set as an example. So what we could do is to set this part here as the base URL for our request, and then maybe there is a request function that autofills these things for us so that we can stick in latitude and longitude depending on what we need. So let's try to make some space here. Let's actually make this into new code chunk, and let's stick this into request first. If we execute just this part here, we see that what we get as a result is an httr2 request, and it makes a so-called GET request to the API we specified. But this still contains the part that we actually do not have as part of the base URL. So for now, let us get rid of this and see how this changes the result. Okay, it seems to have just modified the URL in here. What we can do now is to take this request and pass it to the request URL path append function so that we append further parts to the URL. So we first want to append the points, and then we want to append latitude and longitude. Let's actually fill in the numbers from the example from before. And now if we execute this part, we see that the URL became exactly what we put in there. And now we have the option of replacing this part here with some variables that might depend on the data analysis that we want to run. For example, we could put in the coordinates for different points in the US to get different kinds of weather forecasts. So the idea is clear, and really we noticed that in our web browser we didn't need anything but this URL, so we don't even need to modify our request any further via additional request layers. We can just perform the request, and if we do that, we get a status 200 OK, which means that we got stuff back. And let's save this into, let's call this National Weather Service response. And just to make the names align a bit better, let's call this National Weather Service base URL. Okay, the results still stay the same. Now we have to figure out how to extract the mess that we have seen before. If you recall, we got something back that looks like this with a lot of nested stuff in it. And this is what is known as a JSON format, which stands for JavaScript Object Notation. It doesn't really matter what it stands for. The point is, this is an ugly format, but this is just the standard, so we have to live with it. Thankfully, we have already seen here that we can throw the response to a response function. So let's just do that and put in our response that we had in there. And now what we get back is the mess that we had before, that we've seen in our browser, but now we have this as a list structure inside of R basically. And this really is a mess, and working with APIs is really where your data cleaning skills come out. You will have to make a sense of all of this stuff somehow. And a good way to do that is to use the glimpse function. And if you call this, you will get an error because we haven't loaded the tidyverse yet. So let's do that now. And then we can actually call the glimpse function. Let's make some room here. And this glimpse function shows you the structure of the response, or basically of the nested list. And you can see here, it is a list of 5. And the first list inside of this list of 5 is context, which is a list of 2. And the 2 columns that are contained in this are an unnamed one that has some URL in there, a list of 17 that has some other stuff in there. And this is how you can work your way through this part. You might find even in the geometry coordinates that you have sticked into this. And now to get a forecast for our location, we have to actually look into the properties and use the forecast or the forecast hourly again and follow the URL that is given there. How do I know this? Well, it was described on the API webpage from the National Weather Service. So, I mean this page here, and there it says if you want to get the hourly forecast, use the link that you get in the response. Really get used to reading the API documents, because this is the only way to make sense of all the moving parts in an API. And this one here is actually an easy part. It's all you have in here. It's the full description of what you need to do. In later APIs, you will see that there's way more going on. And this reminds me, if you find this video useful, don't forget to hit the like button, because this will help me feel good about the time I've spent to create this video. So thank you for hitting the like button, and let's get back to the video. In any case, we want to extract this URL, and the plug function helps us to do that. What we can do here is to use the plug function and then go all the way down to the stuff that we need. We see here we need to go into the properties list, and in there we need to go into the forecast hourly column. So let's stick in the levels that we need to go through. First properties, then forecast hourly, and then we get the result from there. So let's save this into a variable called forecast URL, and then we can make a request like we did before. Let's take the same workflow from before, put in the forecast URL as a request. We don't actually need to append anything, and then we can perform the request. So once again, we can save this into a variable, and with this variable, we can evaluate the response by plugging this into response body JSON. And again, we get a highly nested list with a lot of stuff in it. So we first use the glimpse function to make sense of this. And we can see here there's a lot of lists of 16. Okay. And other than that, we see a bit of properties, we see geometry. So I guess let's see what is inside of these lists of 16. And if you've paid attention earlier, you will probably know what is inside, namely the forecast for 1 hour at a time. For each hour, say from 9 to 10, you get a forecast with 16 different points. And the same thing is true for the next hour and the next hour and so on. So let's use the plug function and go into properties, and then into periods. This is still a mess, so let's plug this into the glimpse function. And this looks a bit better. Could scroll all the way up, but it seems to be repetitive. So let's just stay here. This is one list of 16, and it seems like it contains exactly the data that we've just discussed. It always has a start time. So say 11 o'clock in this -5 hours time zone, and the end time. And then it has stuff like temperatures, the temperature unit, probability of precipitation. And since no one can work with this format, we have to extract the things that we want. And we do so by iterating over the lists of 16 and then extracting each value one by one. So as I've said, what we need to do is to iterate over these lists, which means that we can use a map function to do so. In this case, we use the map_dfr function, which means that the function we need to stick into this one needs to give us a row of a tibblback, and this map_dfr will then bind these rows together. So that's why we use an anonymous function that returns a tibble. And now we can specify each column of each tibble. So to extract the time, we need to extract the start time here, which means that we use the plug function with the argument start time to extract this value here. Okay, so to make sure that you understand, right now we write a function here that creates a tibble with one row, and the first column is called time. And in this column goes the value that you get by taking the list and sticking it into the plug function using the start time argument. So this means we iterate over all of the lists, and in each of those lists we go inside of the start time and get this value here. The same thing can be done for the temperature and Fahrenheit. You take the list, again X represents the list that you're currently iterating over, you stick it into the plug function and get the temperature. So this means that you get the value that is inside of this column here. You can do the same thing, let me give you a bit of space here, for probability of precipitation. But if you look at this column here, you will see that this is a list of 2 and you want to get one value back. So we use plug to go inside of this and then go inside of the value column to get this value back. So this is why we use 2 arguments inside of plug here. And by this logic, we can also get a short forecast, which is something like mostly sunny. And if we execute this, then we get back a nice tibble that has for each hour one row with the temperature and the rain probability forecast and the overall forecast. So this is the part where I said this is where your data wrangling skills come in, because you need to know a bit about these map functions to operate this stuff here in a concise manner. And if you wanted to, you could also make sure that this part here right now it is formatted as a character. You could format this as a datetime column by using the appropriate function for that, and this way you get datetime arguments in there, which has a bit of nicer output and you can work with it nicer. Don't worry too much if you didn't get this part here. What you should in any case take away from this is the part of the workflow to even get the response. How you wrangle the data later on, you can do that in any way you want, but for getting the data, you need to follow the httr2 workflow for this. Okay, this concludes level 1 of our API guide. In level 2, we want to get one step further and use authentication. Right now, we got a weather forecast for a place that is given in coordinates. But who in the world thinks like that? Mostly everyone thinks in addresses. So we need something that turns an address to the coordinates so that we can get weather data for the given address. And these kind of services that do this kind of thing are called geocoding services, and Google has one of those. So we need to figure out how to call the Google API with respect to its geocoding service. And to do so, you need to go to the Google Maps API and look for the geocoding API. Just put this into Google or follow this link. All of what I explain here is available in the blog post that corresponds to this video. Link for that is in the description. In any case, this is the getting started guide for this API we want to use. And in here, you find a URL that looks like this. And if we want to do the same thing as before, we can copy this code and put this into a web browser. And there we get, okay, you need to authenticate each request. And this is why you get a request denied. So let us inspect the URL that we have right now. It seems that there is some URL first. Let's think of this as our base URL for now. Then comes a question mark, and then comes address equals, then some stuff that looks like the address that they describe here. So I guess this is the part to make this into URL. And then comes an and the key equals. So the video player in me has enough evidence that this looks like a riddle where we need to find a key and stick that into the URL that we see in here. And if we do that, then we actually don't get a request denied, but we get something back. This of course begs the question, where do we find the key? And once again, this is where the API documents come in handy. And if we scroll up, it actually says before you begin. We probably should have started with that, but no one does that, right? Everyone just skips to the things he wants to skip to. In any case, in this before you begin thing here, you can see that to learn more, set up stuff in the Cloud Console. So I guess this is where we're headed. It looks like there is a step-by-step to do for us. So let's start with step 1, create a new project. And this opens up a new Cloud Console where we have to set up an API so that we can actually work with the geocoding API. Let's call this, I don't know, Weather API tutorial. This is what I have used before for my newsletter where I've already explained all of this. Let's call this Weather Recording. Let's go with that name. So that way I know everything I show you in here. I just delete everything later on, and that way I am certain that you cannot steal any API keys from me. Okay, so this brings us to this page here. If you didn't get to this page first and had to put in some billing information, unfortunately this is something you cannot get around, but all of the stuff with the Weather API here I show you is completely free. You just have to put in some information for authentication. You won't get billed anything if you do not upgrade to a paid tier, which is something you cannot do by accident. So don't worry about the billing stuff here. Okay, in any case, we completed this step. Let's have a look at our to-do list. Okay, we created a project, enable billing. This is what I've just said. Enable API. Okay, so we need to enable the geocoding API, and we have to click on enable. Okay, it is spinning until it is enabled. Okay, so now you see that an API key was generated and you need to copy this somewhere. So let me just copy this part here. You actually need to take good care of this. And what I'm doing right now is actually very bad. I'm showing you part of my API key, but I'm doing this in the knowledge that I will delete this whole project, including the keys later on. So there is no security issue here. But I really want to stress, do not share your API key with anyone, okay? And also do not stick this code into your console or into your R script. If you share your project later on GitHub or something like that, then people can just look into your R console history and look up the key, or they could just look into the script if you put it into the script plain text. And this is why I'm showing you a strategy to avoid all of that. And this involves environment variables. So in RStudio, let me create a new text file and call it .env. Press OK, and this will give you a blank file. Don't put in an extension like .txt or whatever, just call this .env. If you have a repository on what you want to do, you put this .env file into git ignore. Make sure that you commit that change and then you're good to go. You won't be sharing your API keys by accident. So I trust that you have done this now. I will show you now how to save your variable inside of a file like this. What you have to do is to simply come up with a name. Usually they're spelled with capital letters. Let's call this Weather API tutorial. Then you use an equal sign, and then you just throw in the code that you have just seen before. Again, it's very bad that I show you this here. Don't do this at home. This is just for demonstration's sake here. And if you save this, then you can go back to your script, or in my case, a Quarto file, make a new code chunk, and use the .env package, which can load the .env file you have just done. All you have to provide to this is the path of this .env file. If you work from the same directory, just leave it as it is. Since I work from some other directory, I have to put this in there. Just ignore this part. And once you have the correct path inside of that function, you can execute this. And in my case, it will show you incomplete final line found. One tricky thing with this is that the file should end with a complete row. So you need to have a blank row at the bottom. And now if you execute this, you don't get a warning message. And in any case, now your variable was loaded into your environment, which means that you could get your environment variable via the sys.getEnv function. And in there, you just have to use the name that you have put in there. And I do not want you to execute this in your console because once again, then the output might be saved into something that someone could web scrape later on. So this is why we don't execute this now, but we are ready to make a request to the geocoding API. So this means we steal our workflow from the bottom here, stick this in there, and let's call this geocode response. And this one will be passed to the response body JSON function later on. For now, we need to get a geocode base URL, and we get that via the documentation again. In fact, we have already seen this before. It was this part here that comes before the question mark. So let's copy this here and stick this into the variable, and let's use this as our base URL. Now, if we execute only this part here, you can see that the base URL is just the part that we have done before. And now we need to make sure that the stuff that we've seen before, this question mark and the parameters that we need to add, like the address and the key, are added to the request. For that, we have to use a request function. Let's see what we have in store. Let's use the request URL query, because what we have seen with the question mark and the parameters describes the query. So this is the right function we need. And now we can add in the query parameters. In this case, this was address. Let's set this to some address that is in Milwaukee. Little fun fact, this refers to the physics building at UWM where I've studied for 1 year. So a little fun fact about me. In any case, this is the address we're using. And for the key that we need to insert, let us use the variable that we have saved into our .env file. And now if we do not perform the request, but only look at the part that we have in here, then you would see that this modifies the URL, it appends the address, and it also sets the key in here. Again, you probably don't want to execute this code because I'm not 100% sure if this part here gets obfuscated in the output in your R history. So better safe than sorry, do not execute this part. I just wanted to demonstrate this here to show you what happens to the URL, namely exactly what we need happens. All the parameters are filled in with the stuff we've sticked inside of it. And with that, we can make the request. And if we look at the variable, we see once again, there's the address and we get a status okay in there. And with that, we can pass this to the response function again. And since this will be a nested list, let's throw this to glimpse. And in the results, we can actually see that this refers to the physics building. Nice. But we wanted to get the coordinates. So my guess is that we have to go into results, go into the first list, and then go into geometry. So let's do that. Results first, then we go into the first entry because there's another list in here. And then we go into the geometry. And we pass this to glimpse to have a nicer output. And this is a list again, but we can see here that in the location we have latitude and longitude. So let's extract that via another layer inside of the plug call. And we could unlist this and we would get latitude and longitude. And then we could stick this into the coordinates that we have seen here. So that's a way how you could combine API calls to get an address to coordinates and then from the coordinates to the weather forecast. All right, we have completed level 2, which means we can move on to level 3 where we do some AI stuff. We will make requests to ChatGPT. To do so, we will have to look at the API reference of OpenAI, and in there you will find a couple of examples that uses curl. And if you scroll down, you will find another example that also uses curl. This is actually very common because curl is a popular tool to use the command line, like from Ubuntu, to make an API request like the one we are doing from within R. So you will have to get used to seeing something like this, and I will tell you how to translate this, but I will also show you a function that can translate these kind of things for you. You see, if you go into R again, let's create a new code chunk. And in there, you could use the curl translate function. And if you look into the documentation, you see all kinds of examples there. And all of these are valid curl requests. Let's just throw this in there. And that way you can just execute this curl translate function. And it shows you how to transform the curl request to the httr workflow. Similarly, you could do this for other things that use some methods. Or in this case, you could look at something that has something in the so-called headers. You don't actually need to completely understand what these headers are. It's just that they are there. And if you need to stick in something that goes into the header, like A is set to 1 and B is set to 2, then it seems that you need to use the request headers function and set A to 1 and B to 2. And the same thing is true with the last one, where you could, inside of the request perform, also set something like this word here. I have tried this like 3 times already. It's a hard word to pronounce. I have probably cut this out in the video you are seeing, but in any case, this word here, you can set this in request perform. So back in the API reference, if we want to chat with ChatGPT, we will have to translate this request to the httr2 workflow. Unfortunately, if I take this and throw this into curl translate, it doesn't work because maybe there's some issues going on with the escaping here. Whatever the reason, we have understood enough from the examples here to actually assemble our request ourselves. So let's just copy this into our document. And now let's work on the request that we need. So the first thing is the request. It seems like this is the OpenAI base URL. Fine by me. Let's call this OAI base URL. Stick this into a variable and use this variable in the request. And now we need to set 2 headers. And we have seen in this example here, run it again, that there is this request headers function, and we can simply set stuff by throwing this into the function. So let's do that, request headers, and then let's use content type. Let's put this into quotation marks because there's a minus in there. And then we set this to application JSON. That one we have to put in quotation marks no matter what, but for authorization, we can just stick this in there without quotation mark, and then we stick in the part that we have seen in there. And with that, we have a new request that has our headers in there, it has the content type and the authorization, and we can even see that in this scenario, the authorization seems to be redacted. So next we have to figure out how to translate this stuff into an appropriate form. And if we look at this closely, we see that this seems to be JSON.
Jesus Christ, that's JSON born.
It is the same JSON format we have seen before. So let's check if there is a request function that does something with JSON. And it turns out there is request body JSON. And if we look at the description in the documentation, it says this function sends JSON encoded data. Since this D flag stands for data, or if we just assume that it does, then this function makes kind of sense as something to send into our request. So this means that we have to translate this JSON notation into nested lists. So if we look into this function, it says that the data is required, and this is the part where we stick in the nested list. Okay, first thing is model, and it needs to be set to, in this case, in this example, GPT 3.5 Turbo. Then we have messages. This needs to be a list. And then here is another bracket. So we need another list in there. And then we can set the role to user and the content to what we want to say. In this case, we want ChatGPT to say something like, say this is a test. That's kind of boring. So let's ask, what is httr2 in the R programming context? And then we still have the temperature. So let's set the temperature. And this one was set to 0.7. You might be not familiar with what all of these things mean. Like model, you might know that this determines whether you use GPT-4, the more powerful GPT, or GPT 3.5, but you may not be familiar what temperature does. Basically, this is a parameter that helps you to control if GPT answers more creatively or sticks to your instructions more closely. There are a lot more parameters you could modify, and all of this is documented in the API documents. But here I just wanted to give you this little AI information if you want to play more with this. Okay, so let's have a look at our request for now. The body says just something like JSON encoded data. Doesn't matter. But what you couldn't see here is that this became a post request now. You don't need to understand what this is. It's just as a nice information there, a get request and post request. httr2 automatically handles what you need for you. I just wanted to point this out here to appreciate how much this package does for you. So now the remaining thing we need to do is to replace this stuff here with an API key. So let's use the glue function so that we can insert an API key here. And then let's use code in here. And there we use sys.getEnv. And let's say that this should use a code that is OAI API key. We haven't actually defined this key yet. We haven't set this up in our env file. but we can generate one from OpenAI. To do so, we go to API keys, and then we could generate a new one. I've already used one, but since we cannot see it anymore, let's just generate a new one, httr2 video, just so I know to delete this key later on, because obviously you know my key when you see it. So this is why I will just copy this and delete this later on. And now I can stick this into my .env file, and I need to take my code from before because I need to reload my environment variables so that this new variable is loaded into my environment variables so that this function knows how to get this key here. And this reminds me, we should also put in a new line here. Oh, there was actually one, so we don't even need that. And now at the end, we can stick in a request perform. Be aware that if you set up an API key and use it like this, it will actually cost you if you execute this code now, provided that I didn't put in a mistake into the code here right now. But if it runs through, you will make a call to the ChatGPT API, and this is something which will cost you. It will only be a couple of cents right now because we're only doing a small request and the reply likely won't be huge. But just so you're aware, if you don't want to spend any money at all, don't execute this part here. And because I don't want to spend more money than I have to, let's save this into a variable before we even make the request so that I don't have to redo it to get the response later on. Okay, so if we execute this now, it takes a while because it might actually think about stuff. Well, ChatGPT is not thinking about stuff. I just like to say this kind of thing. There's no thinking involved, but it might calculate for a bit depending on how much traffic there is. So this is why it can take a second or two to get a response. In any case, let's check what we get as a response. We will most of the time get a JSON response, so I will just use this anyway without even checking if the documentation says otherwise. And it seems that we even got a JSON response. What a surprise. Let's pass this to the glimpse function. So this is a list that we get back, and in the usage part of this list, you can see how many so-called tokens we have used in our prompt that we passed to ChatGPT and how many tokens it used to answer to our question. So in total, we have used 85 tokens, and on the OpenAI pricing page, you can check how much 1000 tokens for this particular model costs. Again, this might even be like 1 or 2 cents that we have used up here. But still, if you want to be aware of the cost, check the pricing page and you can calculate the cost by comparing with the tokens that you get displayed here. In any case, inside of choices and in the first list, there is something called message. So let's head into that. So we go into choices, then we go into the first one, then we go into message, and then we pass this to glimpse. And in there we see that we get another list with the role assistant, namely ChatGPT replied, and we can extract the content by going into the content cell. And now if we execute this, we get a response that says, in the R programming context, yada, yada, it allows to interact with web APIs. Good enough for me. Honestly, it doesn't matter what it says. We're just worrying about if it works. And it seems we got a response for our question to ChatGPT. So now you're all set to become some AI genius, and now you can join the AI gold diggers to, I don't know, make a crappy app that just is a wrapper around ChatGPT. Good luck with that. But before you try that, let me show you what you can do on level 4 of this video, where we make an even harder request. So let's remove that part here, and this part here can also be removed. We know the structure of the requests by now. So in the last level of this video, I want to show you how to use the hardest kind of authentication, and we practice this by calling the YouTube data API. And since YouTube is part of Google, we can use the same project that we have already used for the geocoding service that we needed for the weather API. So inside of our Cloud Console, we can just go to APIs and services, and inside of this project, check the enabled API and services, and there we can add other APIs. And in this case, we want to add the YouTube data API. So we search for YouTube, and in there we enable the data API. So we enable this. It takes a few seconds, and after that is done, you can generate credentials. So on the credentials page, you can click on create credentials and then make sure that you create a OAuth client ID. And then it will tell you that you first need to configure the consent screen. So let's do that first. So we'll just make this available to any test user with a Google account. We'll just make sure that only our own Google account can use this API. And then we need to put in some name in there. Let's call this YouTube Data API video. And we need to stick in some support mail in there. I will just use my Google Mail for this. And then we can press save and continue, but it actually won't let us because we need to stick in the same email into the developer contact. So let's put this in there as well. On the second page, you can just hit save and continue. As the test user, you should put in your Google account so that you can authenticate using your account. Then press save and continue. Just make sure that in your test users you use the correct email. Sometimes googlemail.com will be for some reason translated to gmail.com and then you will get a warning. Just change that to googlemail.com and then you're good to go. But once that is done, you have successfully put up your consent screen. So this means that you can go to credentials and try again to set up a client. In this case, you will want to set up a web application. Just give this a name. Let's call this YouTube Data Video. And inside of the authorized redirect URIs, put in localhost. So you will need an http://localhost:/ and then some number. Doesn't matter what number you put in there, but you need to remember that number. And once you've done that, you get a successful screen. And in there, you can download all client secret and so on as a JSON. Once again, you can see all of this because I'm showing you my keys. I will delete everything, this whole project after this video. Once again, keep all your client IDs and secret to yourself. Don't give that to anyone. And in this JSON file, you have a whole lot of stuff. And this is the stuff we will need to make sure that the httr2 package can authenticate using the client we've just set up. So let us head to RStudio and set up our environment variables. We need one for the client ID and the secret. So let's call this YouTube client ID. And in there, we get the stuff from the client ID field. It says client ID here. And then we need one for the secret, YouTube client secret. And where it says client secret, we can get the key and insert this in here. And now we have all the things ready to set up the client with httr2. So what we need is another code chunk. And the first thing we do is to reload our environment again. And then we set up the client using the corresponding function from the package. And you can see here that it needs a couple of arguments. It needs ID, a token URL, a secret, and some other stuff. The other stuff seems to be not necessary, but ID, token, URL, and secret is necessary. So let's stick that in there. For the ID, we use the client ID that we've just saved into environment variable. For the token URL, we actually need to get something that looks like this. And in case you're wondering where we got that from, this is also part of the JSON file. In there somewhere it says token URI, and this is exactly the thing I used to stick in here. And then we need the secret, which we get in the way we already know by now. And if we execute this, we get an error because I forgot to change the path of the load function for the environment file. But now everything works smoothly and we have a client that can interact with the YouTube API. You don't need to understand all of these things, what is happening behind the scenes. You just need to know all the parts where you need to stick stuff into, like the client ID and where you get the token URL. And after that, the httr2 package will handle all the things for you. The next thing we need is a YouTube video so that we can get some data for it. To make sure that we're using something publicly available and not something from my own channel where I might not be sure if you can access the data, let's just get one from Ali Abdal. And inside of that URL, you will find the ID of that video. And this is the part we need for the YouTube Data API. So let's save this into a variable. Let's call it video ID. And then we need to figure out what the base URL of the YouTube Data API is. So we have to Google to figure this out. And depending on what we want to do, we have completely different base URLs. In this case, we look for something which lists videos. And it can, according to this description, it retrieves information about a specific video and it uses the ID to identify the video. Seems like it's the one that we need. Don't get discouraged if you click through these documents and don't know where to go next and figure things out. It usually takes a while. It takes me forever whenever I want to work with the YouTube API. It's just what it is. These documents are not easily digestible. So you will just have to live with that this is not particularly easy. But at the end of the day, you just have to figure out what the correct thing is you need to call. And from there, you can get the URL. And at the bottom, it will tell you that you need something like part. In this case, this is a required parameter. And in there, there's usually a list of things that we can stick into part. like ID or snippet or statistics or whatever. And then there are some other stuff that you can try out. In our case, we just have to save the URL into a variable, and then we can stick that into a request and pass the request to the URL query where we stick in the things that we want to add to the link. And in this case, it is part, which we set to statistics, and ID, which we set to video. And in case you're wondering, how did I know that we need request URL query? The thing is, the YouTube API documentation isn't super great, but it has some interactive explorer. And in there you can click on show code and it will show you what you need. And you can see here that it uses the same syntax that we've already seen with the question mark and then key and setting stuff to whatever. You can ignore most of this, but if you, for example, put in statistics into part, you see that it seems to append the part to the URL as a query. So this is how I knew that we will need the request URL query function. And from there, it was easy to assemble this part here. Let's just execute all of this. And then we see that we have a request already, but we need to equip it with the authentication with the client that we've just set up. And this is where another request function comes in, namely the function that can handle this kind of authentication. And if we look at the documentation, it needs a client. That's good for us. We have just set up a client. It needs a URL and stuff like scope and so on. So let's stick these kind of things into the arguments, and then I will tell you where I got what from. So I'll put in the request for the client. I'll put in the scope. I put in the authentication URL, and I put in the port. So you may wonder, let me make this a little bit larger. You may wonder, where did I get this part from and the authentication URL? The URL, this was actually pretty easy. It is also in the JSON file. You can find it here. It says auth URI, and this is the one I have sticked into this part here. The port is the number I have used in the redirect URI. You see, if you go into the console, the number that I have used in this authorized redirect URI, this is the number I have used here. And for the scope, this is something like the permissions that you need. I have just used the API documents. I've just used them in the search bar. I've just put in scopes. And then I clicked on the first thing and scrolled all the way down until I hit a list that tells me the YouTube Data API uses the following scopes. And here I've just used one that was appropriate for what we want to do. We just want to view stuff from YouTube. Okay, so this is why we just used the scope. And now that that all is set, we can perform the request. And now if we execute this code, we actually get an error. It says something here, redirect URI mismatch. So we have to go back into the console and check what's going on there. And in here, it's a really dumb mistake. We forgot to add a slash at the end. For some reason, these kind of things are really allergic to stuff like this. And now if we abort the authentication and retry it, then we at least get to a window where we can choose stuff. So let's choose one account. It will tell you this app isn't verified. Do you want to continue? Yeah, we want to do that. We give rights to view the YouTube account. This was inside of the scopes we've specified. And then it says authentication is complete. Please close this page and return to R. All right, thank you, will do. And now we see that there is a response and we have a status to 200. So let us save this into a response variable. Let's just call this YouTube response. And now we can evaluate this stuff like we did before. So let's put in response body JSON. Let's pass this to glimpse. And in there we can see that statistics is hidden inside of the items in the first list. And then comes statistics. So let's do that. Plug items, first one, and then statistics. And then we see here that there is a view count of 1.47 million, a like count of approximately 40,000. So I guess good for Ali. He has a lot of views and a lot of likes. My channel is not quite there yet, but there's always time. Make sure to watch all of my videos to get my numbers close to these ones here. But in any case, with that, we have figured out how to do this hard authentication, which has a lot of moving parts. So don't worry, you probably have to revisit a couple of steps I did to see what I did where, but this still should give you a blueprint to how to do all kinds of authentication. But let me show you one more trick that will help you to cache keys. You see, this authentication needs to be repeated a couple of times, but if at some point you hit on the wrong account for some authentication, then you might have to redo the authentication. But since the key is usually cached, you won't get asked again which account do you want to use for authentication. So this is why if you put in the cache key argument here and put this to some string then you can re-authenticate again. You might have to log out of your Google account and then log back again to avoid getting this authentication complete immediately. But this is still a trick that you can try out if you run into some debugging issues when you think your code is correct, but for some reasons you get an access denied, which is something that happened to me. So that's why I'm telling you that. But in any case, this completes our journey through the httr2 package. If you have any questions, feel free to drop them into the comments. And if you want to see more videos like this, check out this web development for our video series, or check out this video where I show you how to create some cool data visualizations. In any case, thank you for watching, and I will see you in the next video.